Good day, I will be performing the laboratory exercise 10, DC motor controls. The materials for the exercise are the following: the Arduino Uno R3, the USB cable, the DC motor, the diode or signal diode, the transistor NPN, the BC547 330 ohm resistor, breadboard, connecting wires, the laptop with the Arduino IDE software. In this exercise, we will be controlling the speed of the DC motor using Arduino Uno. First, we must remember these pins. Connect the cathode of the diode to the negative of the DC motor. At the same time, this pin is connected to the common 5V in the breadboard. The positive of the diode is connected to the DC motor positive and to the collector pin of the BC547. Then, the emitter of the BC547 goes to the common GND of the breadboard. Connect a common 5V and GND from the Arduino Uno to the breadboard's common 5V and GND pin lines using wire. Connect the Arduino microcontroller to a power source, in this case a laptop, using the USB cable. Open the Arduino IDE software and enter the code. Verify and then upload. And now, open the Arduino serial monitor. Type a value to set a speed for the DC motor. As you can see, values from the range 150 to 255 were inputted, as values below 150 cannot make the DC motor rotate. The higher the values inputted, the faster the rotational speed of the DC motor. For post-lab question 1, a random sequence of letters or a string was entered in the serial monitor, and the DC motor did not spin or rotate. For the post-lab question 2, we will use a different Arduino pin, in this case pin 8, which is not a PWM pin. The code int motor pin 9 was changed to int motor pin 8. The code was then uploaded. The serial monitor was opened, and the values from the range of 150 to 255 were inputted, as values below 150 cannot make the DC motor rotate. But in this case, any value from 150 to 255 that is entered in the serial monitor can make the DC motor rotate, all in the same rotational speed. And when texts are entered, the DC motor does not rotate. For post-lab question 3, we will replace the code in the new one from the laboratory exercise guide. After uploading the code, the DC motor starts spinning at high speeds for 2 seconds, then stops spinning for 2 seconds, and repeats spinning and stopping in a loop. The run and stop values from the code were changed to 10,000 and 200 respectively. The code was then uploaded, and significant changes to the output of the DC motor were noticed. The spinning time and stop time of the DC motor corresponds to the changes in the code. The spinning time of the DC motor is 10 seconds, the same as the new run value, which is 10,000 milliseconds, and the stop time of the DC motor is 200 milliseconds, the same as the new stop value, which is 200 milliseconds. That would be all for this video. Thank you.